New NASA research indicates that Saturn's iconic rings are not only younger than previously thought, but also that these rings are actually disappearing at an extremely fast pace. The research found that the rings are draining away toward the planet as a dusty rain of ice particles. Saturn's rings consist mostly of water ice that ranges in size from microscopic dust to large boulders. Ultraviolet light from the sun and plasma clouds coming from tiny meteoroid strikes charge the icy dust, which then becomes bound to Saturn's magnetic field and pulled into the planet by gravity. This material rains into the planet and begins to disintegrate, allowing it to react chemically with the electrically charged part of Saturn's upper atmosphere, the ionosphere. The ions glow in an infrared light as part of this process if the rain is light, but the emissions dim if the rain is heavy. This was observed using instruments attached to the Keck telescope in Hawaii. The rate of disappearance in this ring rain study has allowed scientists to infer that Saturn's rings formed less than 100 million years ago. This means Saturn wasn't born this way, as the planet is known to be over 4 billion years old. And when the ring rain data is combined with observations made by the Voyager 1 and 2 missions, scientists from NASA Goddard are able to estimate that the rings will be gone in 300 million years. So if this rain doesn't go away, Saturn will be ringless another day.
My name is Bridget Hessman, and I'm a planetary scientist at NASA's Goddard Space Flight Center, and I study storms on Saturn. A great white spot is a massive storm system that erupts on Saturn about once every Saturn year. The great white spot that erupted in December 2010 first presented itself as this fluffy white storm cloud that popped up in the northern hemisphere. The storm, when it erupted, sent large waves up into the stratosphere, and we saw effects like an increased amount of ethylene, something we never expected to see. In the coming days, the winds on Saturn sheared the storm in both directions, and it wrapped all the way across the planet. If you were to scale that to a storm system here on the Earth, what you would have is a storm system that covers all of North America but wraps around the entire planet. There'd be no escaping this storm system, and it would be lasting for a very long time. This great white spot happened to occur 10 years before we expected it, which was very fortunate because we happen to have a spacecraft called Cassini in orbit around Saturn. And that spacecraft has a full suite of instrumentation that allows us to study this over all wavelength ranges. Some of the effects that we got to see in the infrared were these two bright beacons that started to shine right after the storm erupted in December. Those beacons at first showed temperature differences of about 20 Kelvin, which is reasonable for a storm. However, as time progressed, we started to see even larger temperature changes. By May 2011, the two beacons had merged into one, and we saw a temperature change of over 80 Kelvin from the quiet conditions before the storm. So that would be like going from the depths of winter in Fairbanks, Alaska, to the height of summer in the Mojave Desert, all in one storm system. Can you imagine what that would feel like sitting on your deck? We'd never before been able to study a storm system of this magnitude in the infrared, so we are very fortunate at this time to have a spacecraft in orbit allowing us to make a historical record of this great white spot.